Okay, so we're beginning now to look a little bit more at graphs, and we introduce the idea of functions and relations. We begin by defining this idea of a relation or a relationship. A relation is a mapping or an assignment from one set A to another set B. So, in other words, it takes elements or things in A and maps them or assigns them to things in set B. So objects in A are mapped to or assigned to or related to objects in set B. Okay, that's what the relation does. Now in set A, you may have some things, and we'll see this in an example very shortly, that do not get related to set B. But the set of objects in A that are related to something in B, which would be a subset, is actually called the domain of the relation. So sometimes there'll be certain things in A that don't get related to anything. So then they're not part of the domain. But the things that do get related to stuff, that is part of the domain. Now, likewise, in set B, you'll have stuff that has things being mapped to them. And then you may have stuff that doesn't have anything being mapped to it. That's called the range. And so we define the set of objects in B that have something being related to them is called the range of the relation. And again, we go back, and that's the blue set that I've circled there. The range, again, is the set of things in B that have something being related to them. And so that's called the range of the relation. And you'll see a little better as we do an example or two what we mean when we talk about domain and range. For example, consider the following group of 3 students: Eric, Jill, and Bill. Eric is 21, Jill is 20, and Bill is 14. Our relation we're going to define as is older than. So if we take our group of 3 students, Eric, Jill, and Bill, write those down as sets A and set B, then Eric would be related to those people that he's older than. Eric is older than Jill, being 21, so Eric would be related to Jill. Eric would also be related to Bill, because Eric is older than Bill. Jill is also related to Bill because she's older than him. However, Bill is not older than anybody, so Bill does not get related to anyone. And so, if we talked about our domain now, those things that actually get related to something, that would be Eric and Jill. Bill is not part of the domain because the relationship doesn't relate him to anyone. And so therefore Bill is not part of the domain. And likewise, the range, the set of things in the other set there that have stuff being related to him, are Jill and Bill. Eric does not have anybody related to him because nobody is older than Eric. And so therefore Eric would not be in the range of our relation. There are several ways that we can represent relations. Using a diagram like this is one of those ways, where you list your elements in one set and your elements in the other, and then draw lines to connect the things that set A is related to in set B. So what we're going to look at are some examples of the different ways that we can represent relations. And as we do that, we want to look at their domain and range. So one is, again, using a diagram like this. So here's our relation, taking things from set A, which is the letters A, B, C, and D, and mapping them or assigning them to things in set B, which consist of the numbers 1, 2, 3, 4, and 5. And so that's our relation, and now we're going to look at finding the domain and range. So for the domain, we would look in set A at each thing that actually has something being related to it. or is actually being related to something. And that would be the letters A, B, and C. D does not have anything, is not related to anything, so he does not get to be a part of the domain. Then we can talk about the range. So we look at set B, and everything that has something being related to it. That would be 1, 2, 3, and 5. And so we'd write that down. 4 has nothing being related to it. He's left out, and so therefore he's not part of the range. So that's one way to represent a relation, is as a diagram like this. We can also represent a relation as a set of ordered pairs. So in this case we have the set of ordered pairs 1, 2, 1, 3, 4, 2, 5, 1, and 3, 3. Okay? And so here we look at all of our x values as being in set A and our y values as being in set B, and again we can determine our domain and our range. Now when we write down those x values, which you can see I've underlined them all there, we don't repeat them. So the fact that 1 shows up twice, well, that's kind of like the A above there. A gets sent to 1 and 2 in the problem above. 1 gets sent to both 2 and 3, but we only write it down the one time. And when we talk about the range, we look at our set of y values. And again, we write down the y values. Again, no need to repeat. The fact that 2 and 1 were, or the fact that 2 and 3 were repeated in that list, we only write them down the one time, so the range would be the set 1, 2, 3. In our next example, we consider a third way that relations can be described, and that's in terms of a graph. So here we have a graph with points being plotted. We can translate this as our x values, in this case 1, gets related to 2, 3, and 4. 2 is being related to only 3 and 4. 3 is being related only to 4. And 4 over there actually doesn't get related to anything. And in like manner, 1 on our graph there, the 1 has nothing being related to it. So you could basically take this graph and translate it into ordered pairs, like we did in the last example, and then talk about our domain and range. Or we can kind of examine it and say, okay, what x values actually show up? And then we could say, well, for our domain, the x values of 1, 2, and 3 show up as having something being related to something. So that would be part of our domain. That would be our domain. For our range, we'd look and say, well, our y values are 2, 3, and 4, and so that would be our range of our relation. Okay, in the next video we're going to talk about functions and how they relate to relations. We're still going to be using this idea of domain and range, and so we'll pick that up in just a few moments.